Two particles are moving along two straight line at with the same speed 20 meter per 20 centimeter per second. The angle between the two lines is equal to 60 and their point of intersection is O. At a certain moment, the two particles are located at a distance of 3 meter and 4 meter from O and are moving towards O. Find the shortest distance between them. Now let us consider this as the origin O, and there is a particle situated at point A, okay, and this is the x-axis, and it is approaching O with a speed of 20 centimeter per second, okay, and now its distance along the x, let it be equal to 3 meter over here, or 300 centimeter. Now if I consider another line which is inclined at 60 degree, okay, and another point B, okay, it is approaching the point O with a velocity of 20 centimeter per second with the same velocity, and now the distance over here is equal to 4 meter, okay, the distance from O is equal to 4 meter. So basically, let us first find out the position of A at any given time t. I can say that the position of time of x2, the final position of x2 will be equal to x1 plus vt, okay, this is the formula of the displacement, okay. So basically x1 over here is equal to 300 centimeter, okay. Now the velocity, since it is in the negative direction, it will be equal to velocity, since it is in the negative direction, it will be equal to, since it is in the negative direction, it will be equal to minus 20 into t, okay, at any given point. This is the position of x2, okay. The position of x1 basically, okay, or this is the position of x2 or the particle A, okay. For particle B, the x1, the x position will be equal to, initial position over here is, now this is 4, this is 60 degree, okay, this is 4 meter or 400 centimeter, and this is 60 degree. So basically this will be equal to 400 cos 60, which will be equal to 200, okay, plus the velocity in the x direction. Now the velocity in this direction is 20, so in the x direction it will be equal to 20 cos 60, which will be equal to 10, okay, and since it is in the negative direction, it will be equal to minus 10 into t, okay. This will be the x position, or the position of the particle B at any given time. If I simplify this part, x1 can be written as 200 minus 10 into t, okay. And if I say the y position of the particle, initially it is located at 400 sin 60, which is equal to 200 root 3, okay. The same formula, instead of x1 it will be y1 plus vt. Now the velocity is again in the negative direction, so it will be equal to negative, the velocity is equal to 20 over here. In the downward direction, it will be equal to 10 root 3 into t, okay. So these are the general positions of A and B at any given time, okay. Now basically the distance between them will be equal to root of x2 minus x1 plus the whole square plus y2 minus y1 the whole square, okay, x2 minus x1 the whole square plus y2 minus y1 the whole square, which can be written as, if I subtract both of them, x2 minus x1, 300 minus 20t minus 200 minus 10t, which will be equal to 100 minus 10t the whole square plus y2 minus y1, okay. Y2 is anyway equal to 0, okay. The A particle does not have any velocity, neither the displacement in the y direction, so it will be just equal to y1 square. So basically it will be equal to 200 root 3 minus 10 root 3 into t the whole square, okay, the whole square. This is the displacement. Now in order for the displacement to be equal to 0, ds by dt should be equal to 0, okay, that is the relative displacement should be equal to 0. So basically when I differentiate this part, the root part gets cancelled out, okay, and this part when I differentiate, it will be equal to 2 times 100 minus 10t, okay, into minus 10, okay, plus 2 times 200 root 3 minus 10 root 3, okay, into t into minus 10 root 3, this will be equal to 0, okay, this will be equal to 0. So basically I can say that if I divide the whole equation by 20, okay, if I divided the whole equation by 20 or 20, it will be shifted on the left hand side, so it will be equal to 100 minus 10t, okay, 100 minus 20, 10t, plus it will be equal to 200 root 3 minus 10 root 3 t into root 3 will be equal to 0, okay, will be equal to 0. When I multiply 100 minus 10t, okay, 100 minus 10t plus 200 root 3 into root 3 will be equal to 600 minus 30t will be equal to 0. So basically 40t will be equal to 700, or t will be equal to 70 divided by 4. Okay, now I got the value of t is equal to 70 by 4. Now I will substitute in this formula. Okay, 70 divided by 4. Okay, s will be equal to, the minimum displacement over here will be equal to 100 minus 700 divided by 4, okay, the whole square, plus it will be equal to, when I substitute the value of t over here, it will be equal to 200 root 3, okay, it will be equal to 200 root 3 minus 70 by 4. So 700 divided by 4 into root 3, okay, 700 divided by 4 into root 3 the whole square. Okay, so basically it will be equal to, basically when I cross multiply this part, it will be equal to 400 minus 700, it will be equal to 300 divided by 4 the whole square, okay, plus over here it will be equal to 800 minus 700, so 100 root 3 divided by 4 the whole square. When I take 4 outside the bracket, outside the root, it will be equal to 1 by 2. Okay, let us sort out this part. Okay, it will be, I can take 100 also common over here. Okay, I can take 100 also common over here. It will be equal to 3 square plus 1 square. Okay, it will be equal to 9. Okay, 9 plus over here it will be equal to 1 into 3, it will be equal to 3 over here. Okay, 3 square, it will be equal to 3. Okay, so basically it will be equal to 50 into root, okay, or 50, it will be, this will be 4, okay, this will be 4 over here. So I can say this is 100 divided by 4 into 9 plus 3, which is equal to 12. So 50 by 2 root 12, which can be written as 50 root 3. So the minimum distance between them will be equal to 50 root 3.